Hi guys, welcome to our last day of linear programming, day 4. Again, these long problems that take some time, 15-minute video. I don't know if I'll get to all 4 examples that I have, but again, they'll be there for you to look at notes. If we do have time, we'll get to them all. What I want to do is skip number 1 because it's a little bit more straightforward like we've been using, and I want to instead do example 2. It's very appropriate because it helps you with your project in particular, and you may want to write this down when you're dealing with, I think it was the vapor pressure and what was the other one? Some type of additive. Maybe it was lead. But those had weighted averages. That's the idea, and that's what we're going to focus on right now. So I'm going to title this weighted average. And again, the idea is this. I'm going to skip to a blank page. It'll take a little bit. If you had 3 70s and 190 on a test, is your average an 80? And I would say, well, of course it is, because halfway between 70 and 80 is 90. And you'd say, no, I've got many more 70s, so therefore my average is going to be lower than 80. It's going to be somewhere in the mid-70s. Because how do I do it? Well, there's 3 70s, there's 190, and we're going to divide that by the total number of tests. 70 times 3 is 210, plus 90 is 300. 300 divided by 4 is 75. I would have a 75 average. Because again, the two choices of 70 and 90 were not equal. I'd expect my average to be lower than the middle of those two. Add them up. Total number of tests, 3 plus 1 is 4. 3 70s, 190, 300 divided by 4 is 75. All right, let's do the same thing here. It says D-Light Milk Company gets milk from 2 dairies, blends it together to get the desired amount of butter fat for the company's premium product. I don't know, maybe ice cream. Dairy A can supply at most 700 gallons of milk. That sounds like a constraint. Average butter fat, 3.7%, costing 90 cents a gallon. Dairy B can supply milk averaging 3.2 butter fat, costs 75 cents. So it sounds like Dairy A is better quality milk in terms of the butter fat, but a little bit more expensive. How much should D-Light buy to produce at least 1,000 gallons of milk? And it has to have at least 3.5% butter fat. And what will that cost be? And if it's cost, I want to minimize cost. So let's start with our constraints and our decision variables. X equals gallons from dairy A and gallons from dairy B. Oh, 700, because dairy A is small, so X is less than or equal to 700. We have to make 1,000 gallons of milk. Now, we could make more, but we can't make less. So X plus Y is greater than or equal to 1,000. Now we're going to do the weighted average butter fat. This is where the weighted average comes in. And again, it's just like your grades. X gallons from dairy A, that's how many tests you got in a certain grade. 3.7% butter fat, that's the grade you got. So 3.7X plus 3.2Y, that's the sum of your grades, divided by the total number of tests, or in this case, the total number of gallons, and it has to be at least 3.5%. It could be greater, sort of like you need at least a 90 to get honor roll. Greater than or equal to 3.5. Now we're going to get ready to graph these three. I'll graph the 700 in red, the X plus Y in green, and we'll do the weighted average in blue, but we're going to have some work to do. And that is we're going to have to solve that system. So first of all, let's label our scale. Here's X, here's Y, dairy B, dairy A. And I think if we go by, each box can be 100, so 200, 400, 600, 800, 1,000, 1,200, and I better go times 100. 200, 400, 600, 800, 1,000, or 1,000, 1,200, again times 100 gallons. What did the first one say? It said maximum number from dairy A is 700. What color did I say I was going to do that in? I'm going to do it in red. So I got a vertical line at 700 going left, less than. My second one I said I would do in green, 1,000, 1,000. At least to make that many gallons. So I got a line. And it's going to be shaded up from there. So right now I'm in the top left-hand corner. And then the last one, we got to do this a couple steps. 3.7x plus 3.2y is greater than or equal to. I'm going to multiply that x plus y times both sides, canceling out on the left, distributing through on the right. Now I want to get the y on the left side. 3.2 minus 3.5 is negative 0.3y is greater than or equal to x on the right side, negative 0.2x. Divide by negative 0.3, y. Dividing by a negative, flip the inequality. Negative 0.2 divided by negative 0.3, negative divided by negative is positive. Get rid of the decimals. Y is less than or equal to 2/3 x. Here's how I'm going to graph that. Old school. The slope rises 2, run is 3. 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 That looks like enough to get our feasibility region. And we are going greater than, nope, flip to less than. So if we are above the green, below the blue and left of the red, we have a very small feasibility region right in there. And I see 3 corners. One there, and one there. What are they? Well, the red-green one's pretty easy. That's 700, 300. So let's call that 0.1. But what about 0.2 and 0.3? Well, we can solve our system. So 0.2 is red-blue. So 0.2 is red-blue, which would be red, x equals 700, blue, y equals 2/3 x. So if I solve that system, I would get, if x is 700, plug 700 in, 2/3 of 700, y equals 466 repeating, 0.6 repeating. But again, if it's got to be in the feasibility region, and I'm down below that, I've got to go down because 7 would round out. I know it's a small detail, but 466 would be the max you could have. So there's our second point, 700, 466. 0.2, 700, 466. I don't think I meant to say that 730. I meant to say 700, 300. And then 0.3. What do we got there? A little bit easier point. That's right on the money, 600, 400. Got it. Got it, got it. Now we need an objective function to plug into. What do we have? We have cost. Dairy A is 90 cents a gallon. Dairy B is 75 cents a gallon. So cost equals 90 cents a gallon for A, 75 cents a gallon for B. So P1 is 0.9 times 700 plus 0.75 times 300, and that money is $855. Option 2, 700, 466, 0.9, 700, 0.75, 466. That's $979.50. And 0.3 is 0.9, 600, 0.75, 400, cost $840. What are we looking to do? We're looking to minimize cost. Cheapest one is right here. So, 2, minimize cost. And again, meet all constraints. That's what we did. We addressed everything at the same time. Purchase 600 gallons of milk from Dairy A and 400 gallons from Dairy B. For min cost $840. All right, weighted average, again, something you're going to use in your project related to the vapor pressure and the, sulfur content. That's what it was, not lead content, sulfur content. My bad. All right, time's, I got about 13 minutes in. I guess we were only getting through one example. I'll do a part 2 on this video like I have been doing, and we'll do 2 more examples.